Section 8.2, we are going to use the principles from section 8.1 in order to find y when dy by dx is given in the form of an multiplied by x power n plus an minus 1 multiplied by x minus 1 plus so on until a 0. Then now we are going to have a polynomial expression. It can be addition or subtraction in between the terms. Therefore, in page 136, it says you can apply the principles of integration separately to each term of dy by dx. For this purpose, let's take example 3 in the same page, where dy by dx equals 6x plus 2x to the power minus 3 minus 3x to the power 1 over 2. Find y. As you observe, we have different terms in this expression, and these terms are added and subtracted from each other. Therefore, in order to be able to find y, so we are going to remember both formula that we studied previously. When we have dy by dx equal x power n, then y equal 1 over n plus 1 multiplied by x to the power n plus 1 plus constant. And when we have dy by dx equal k to the multiplied by x to the power n, and then y is the constant over n plus 1 multiplied by x n plus 1 plus c, and we have to take into consideration always n does not equal to minus 1, and as long as we have a constant, this is called indefinite integration. So let's move now to example 3. Given again, we have dy by dx equal 6x plus 2x to the power minus 3 minus 3x to the power half, and we are asked to find y. We have different terms, and we know from these terms that there is a constant multiplied by x. Therefore, we are going to use that formula when k multiplied by x power n. Therefore, now we can say y equal the integration of dy by dx will be y. But how we are going to do all the terms? Let's do the integration for each term separately. First, the first term is 6x, then k equal to 6 and n equal to 1, the power of x. Therefore, applying it in the formula, the integration of 6x is going to be 6 over 2 x to the power n plus 1 is going to be 2, equal to 3x squared. So this is the first term. The second term is plus 2x to the power minus 3. Therefore, k is equal to plus 2 and n equal to minus 3. Now, applying these given in the formula, we will get 2 over n plus 1 is going to be minus 3 plus 1 is minus 2. Then substituting it, we will get plus 2 over minus 2 x to the power minus 2. Plus 2 over minus 2 is minus 1 multiplied by x to the power minus 2. Now moving to the third term, we have minus 3x to the power 1 over 2. Therefore, k is equal to minus 3 and n equal to 1 over 2. n plus 1 is then equal 3 over 2. Applying or substituting these given in the formula, we will get y equal, or the integration of minus 3x x to the power half is minus 3 over 2 multiplied by x to the power 3 over 2. This is equal to minus 3 multiplied by 2 over 3 x to the power 3 over 2. This is going to be minus 2x to the power 3 over 2. Now we can write all of these terms, or the integration of these terms, in front of y. So y is equal 3x squared, the first term, the integration of the first term, minus 1 or minus 1x to the power minus 2, the integration of the second term, and minus 2x to the power 3 over 2, the integration of the second term, plus a constant. We have always to remember the constant. Therefore, it's equal to 3x squared minus x to the power minus 2 minus 2x to the power 3 over 2 plus the constant. We did not find the constant, or we did not write the constant in each term, but we wrote it just in y. So we integrated each term separately and then substituted in y, and we added the constant c. This is an easy forward example. Back to page 136, it says in chapter 7, you saw that if y equal f of x, then dy by dx equal f prime of x. Previously, in the previous chapter, we used f of x and f prime of x. And in this chapter, sometimes we are going to say dy by dx, and other times we are going to say f prime of x. So you have to keep awake and know that it's the same.